mode.
Hi, everyone. This is Lynn Strand, and I am the chair-elect of the Competitive Intelligence Division. And we're just going to wait a few more minutes and get a couple more people on the line here, and then we'll get started. So just hang tight, and we'll be right back. Hi, everybody, and welcome to Competitive Intelligence in a Big Data Era. This is Lynn Strand, and I'm the chair-elect of the Competitive Intelligence Division of SLA. And we are delighted today that Brooke Aker from Manzama is here to give us this presentation. And we also want to thank Aurora WDC for being our host. And a few housekeeping notes today. Everyone is in listen-only mode, which you heard earlier. And we're going to have the questions at the end of our session today, but please feel free to ask them as they come up for you in the chat box. And then at the last 15 or so minutes, we'll address those. So with that, I'm going to hand it over to Brooke.
Very good. Thank you, Lynn. Welcome, everybody. Appreciate you signing in, making some time for us today. I wanted to talk a little bit about a couple of different aspects of big data and how it plays a role in competitive intelligence, your particular area of expertise. So you know a little bit about me. You can see my picture there and some other background information. Lynn and I were just laughing, saying I've launched myself into various startups 4 or 5 times over the course of my career. It's just who I am. It's what I do. I was lucky enough to cut my teeth in the competitive intelligence world way back at the Futures Group and under Jan Herring, who I trust most of you know as a sort of founding father of competitive intelligence here in the U.S. I got to learn the skills of competitive intelligence from him. We traveled the world and helped corporations establish their CI function. Somewhere along the line there, I got enamored with the technology that might support the methods of CI and founded Cipher Systems, which still exists, although I long since have left Cipher Systems to do other things. And I went on to do other things because I really got enamored with predictive analytics, big data. This was all through the period when the internet was swelling larger and larger, and various types of technology became available. I felt it was my mission to understand those technologies and try to apply them to the methods of competitive intelligence. And my firm is called Big Data Lens, and I also double down as chief data scientist at Manzama, who is a fascinating firm, and I hope you will give them a close look when you get a chance. And I'll make a suggestion that they are providing the kind of service. It's a real sweet spot, what I call a Goldilocks zone for information acquisition and analysis, which you'll see in a little bit. So I do know a lot about where you are coming from in the CI world, but I also happen to know a lot about large data and predictive analytics and models and machine learning and all kinds of other buzzwords. I found this updated definition for CI, which I really liked. We used to use a much more strict version of this in the Futures Group days. But I like this idea of early identification in a marketplace, not strictly just competitors, but the market overall, the environment in which your corporations must operate before they become obvious. This is very, very clear to me. There is no such thing as intelligence if you can pick up the paper and read the stock quote of the day, etc. What we all are engaged in is the forward look, and of course, not so long that it isn't impactful to the corporation, but certainly far enough out that it hasn't yet been reported anyplace, or that it becomes, in this case, obvious. So it's an interesting area to be in, and I've titled this a little bit off of what the title was for when you signed up, just really competitive intelligence in this information or big data era. I also like to review, for those of you who don't think about competitive intelligence or are fairly new to it from a methodological perspective, I can't overemphasize this very simple diagram, and I hope you have seen, for most of you have seen it many times, the central idea here being planning and direction, and it's a simple notion. You can't ask for everything when it comes to understanding your environment, or you'll never get there. So ask your sponsors, your executives, what it is that they need. I almost venture to say force them to reduce or be clear about both what they want so that it's focused, as well as how they will use what you produce for them. Without those two things, you simply are reporting facts and not really creating intelligence. So this planning and direction is absolutely vital to focus the effort. As soon as you do that, you increase the chances of success in collecting public and private data, applying analysis, and then supporting executives and their decisions to optimize resources, to outmaneuver, to outsmart, to build another product, to invest in a new plant, etc. That planning and direction sometimes is called KITS, another Jan Herring era sort of invention, or skip era invention. And it's, again, that simple notion that says, what is it you need to know? Is it future-based? And is it focused? So that's a KIT. It can be what is on the minds of an executive, but I've tried to give some simple examples of what a bad KIT is versus a good one. What is competitor X doing? You could turn that around and say, what are they not doing? It's sort of like asking whether it will rain or not. And the answer is yes. It's just a matter of when. But a good KIT instead is, when will competitor X launch their new product? So you can see the elements of when, so that's a time, and it's very focused, launch a new product. So there's some prior notion that competitor X is up to something. This is too broad, and this is much more focused. Chances of doing this well to the satisfaction of your sponsor are almost nil. The chances of achieving this and getting a solid answer are pretty good. You do that because kits become what are called kicks. And again, I apologize to anybody who's been at this a long time and practices this way, even if you don't use these acronyms. But for those of you who are new, breaking a problem down, even after forcing or working with an executive to get more focused on their kit, your job is to then take that and break it into small chunks. And so from left to right on this chart, I've tried to give a very small example of what that looks like. When will competitor X launch their new product? You turn that into, let's say, 4 simple little Smaller projects, have they received any regulatory approval, assuming that's necessary for their new product? Have they placed supplier orders? Have they retained an advertising firm? Have they hired staff to support the product? Off you go, looking for a preponderance of evidence for each of those so that you can answer those kicks in simple fashion: yes, yes, no, and yes. 3 out of 4 gives you the conclusion that competitor X will launch within, next 2 quarters. These are very simple methodological but very powerful ways of boosting your chances of actually creating the intelligence. Now, this is a long-standing method. What is new is big data. Data's been around forever. The internet came along and gave us, a new library of information. News services were added to that, so now you had streaming information. The internet gets larger all the time, doubles every, 18 months or something. And then social media came along, and so on. This gets bigger all the time. It's a fantastic array of material, but of course it isn't the only source of information. I have put down here private data. For those of you who've been in the CI game for a long time, you know that lots of valuable material is hidden or it's private. So not all technology can solve the information problem, can get us a long way, but what I like to point out is focusing on public data and now social media, and that, by the way, that includes not just person-to-person social media, but it can certainly include corporate social media. Between these two, you often get interesting pointers to the right people that you might want to elicit additional information, that private data. The person you might want to pick up the phone and ask to have 15 or 20 minutes of their time. That might be the author of an article back on the web. It might be some interaction between 2 corporations that you didn't know existed. And you see names in social media. There are all kinds of pointers here that give you access or a starter set to acquiring that additional private data. Of course, there's lots of government data these days. Data.gov, try that one. You'll see a fantastic array of what the government publishes in a fantastic array of formats. And I encourage you to look that over, all of which is your public tax dollars at work. So an enormous array of material. Here's another really interesting way that I came across not so long ago that I think, this is a direct cop from the FBI. This is how the FBI thinks when they're trying to profile a person. And while some of this doesn't apply in trying to profile a corporation, the thinking behind it, I think, is illuminating. And I like to boil it down to 3 Bs: biometric, biographic, and behavioral. So biometric: shape, size, placement, etc. And these are all, of course, about individuals, as you see here. But they can be financial, they can be product set, they can be, etc. They can be the size, shape, and composition of a corporation. And then the biographical, so height, weight, color, address, you see these things over here. So this is the history, both of a person, but you could replace a good deal of these as well with historical records of a corporation. And finally, this idea of behavioral. So if we know size and shape and we know history, what we also want to do is observe current behavior. What is it they do? How do they do it? Where do they do it? Etc. And that's the kind of thinking you see listed here. So 3 Bs: biometric, biographical, and behavioral. Now, when we get to technology and the use of big data, I like to think of this idea of a Goldilocks zone. And this brings me to recommending Manzama after getting to know them very well. Their whole notion, their whole mission in life is to find, filter, store, and deliver exactly the type of information that's impactful for your job at hand, and also giving you an ability to quickly develop and add or subtract to what is delivered to you. And I say it's Goldilocks zone because if you think of the internet as or all the sources of big data as this giant wheel on the outside, it's too much. You can't effectively use Google to do that, or any giant search tool to do that. Number one, from a data perspective, the way in which the index is created on Google or any large search engine, it's thought of from the IT perspective now as a bag of words model. What I mean by that is Google and Yahoo and the rest literally do not understand what the page contains. They are simply treating every word on the page as if it were in a bag of words. So yes, while you pull up a news article and you read it, it looks logical, and because the way you read it from left to right, sentence from top to bottom, paragraph after paragraph, that's not how Google sees it. You can do this experiment for real, but just think about it for a minute. If you took all the words on any page that you see, that a Google search result that you received, and you stripped all the words and you put them in that bag and you shook them up and you spilled them back onto the page in such a way that they were all mixed up, Google wouldn't know the difference. They would be exactly the same to Google because it's only indexing the number of words, the frequency of words across the page. Now, there are some exceptions to that, but generally speaking, that's true. So using giant search engines when they give you lists of thousands of results, of course, is an impracticality. You cannot review all those. You can't read those. Neither can you rely on a small set of internal documents in order to solve your kits and your kicks, or to create competitive intelligence, or to predict anything. There just isn't enough information. It's too cordoned off from the rest of the world. So what is in the middle are very good tools like Manzama to crawl, index, but add extra sets of information, sometimes called semantic layer of information, on top of that bag of words idea, so that when it's time to build a filter and deliver that information, it's just right, or it's that Goldilocks zone. And I was screwing around this morning actually trying to generate a word cloud of every competitive intelligence analysis technique I could think of, and I had at least 50 or 60, but I couldn't quite get them to generate in a word cloud in the way that I wanted. So here's at least the set that that came to mind and fit on the screen. The only point here is that some work better than others. There's lots to pick from, and we don't have really a lot of time to go into any of that today. I will show you a few of these in action, particularly the one at the bottom, which I'm fairly certain you're unfamiliar with, which is a little bit of a combination of Monte Carlo simulation and this TSA, which stands for Technology Sequence Analysis, a fascinating old but new again technique that allows us to project forward on the shape of technology-based products, which I'll show you in a minute. Oops, excuse me. I see I'm ready to do that. Okay, so let's go through a couple of things when it comes time to utilizing data and predicting for intelligence purposes. So I'm going to jump out of here and go back to my desktop so you can see these various things. So let's do this one first. I apologize, the screen is probably a little bit squeezed for you, but stay with me on this. What you see in front of you is a real example. This is from Life Sciences And what we've done is utilize some of the technology I've talked a little bit about today, and applied a natural language processing or semantic processing technology that we have created at Big Data Lens in order to not just acquire all patents from two different companies, but then to look for commonalities among them. So process all the language in the patents, and then cross-compare them. So everything you see in this list is one competitor, and everything you see across the top is the same set from another competitor. Now, when you model this correctly and use predictive analytics or machine learning on top of that natural language processing, so tearing into the patent and training the model to look for methods of action methods of actions and claims, which is the common way a patent is describing what's going on. So what goes into it, what goes into the invention, and how does the invention work? That's what that means. So method of action and is the input, and the claim is the output. Then you can allow technology like this as a finished product or as an analytical technique to be able to sort on different dimensions of the data, so you can see where things are common in this area here versus where they are less common or not common at all. So where does one company concentrate their both methods of their inputs and their outputs? In this area here, these are where they're the same. And that either means, because there's no escaping that, you must have certain types of inputs and outputs in order to achieve. But there are plenty of other areas in which they differ. So your intellectual property portfolio relative to someone else's can be looked at in this way. So you can do that, again, by claim or by method of action. So this is a very powerful way to look at the commonalities and perhaps where not so common. So where are we the same and where are we different? This is a powerful way to bring both intelligence as well as interactivity into the decision making. Remember our kit wheel, which is decision making with executives. So giving not just answers, data acquisition, reports, slide decks, and whatnot, but applying the predictive analytics or some other technological way of bringing some of that data to life so people can walk around it, ask questions, view it differently, and think about it actively. Let's see. Let me bring this one back up. Went to sleep. Here is a model. This is real data. This is a predictive analytics model on competitor product launches. So that same kit process, working through those, the example was given, when will they launch the new product? We check for certain things. When the preponderance of evidence suggests they're going to launch, then you've got something you can work with, both historically and into the future. And again, the visualization of this is helpful as you wander through. So here, for example, is a gap. This is us versus all the others. And this gap gives us a time frame from here to here so that we can focus our efforts. If we know ahead of time, predictively, competitors are likely to dip for a number of reasons. They're exhausted by prior launches, they're stuck financially, they haven't reached regulatory approval, etc. As opposed to you being on the upswing, it's this kind of visualization where the gap appears and the length of that gap gives some credence to say, yes, keep investing, or hustle and get it out the door before they catch up appear and surpass us in terms of product launch. Again, it's data in, analytical methods, and then this interactivity when it comes time to supporting decision makers overall. This one went to sleep also. Hold on. Now here's a very simple idea as well, and it demonstrates raw information in and some analysis on the outbound. And again, it's interactive. This is it takes a moment to run. It's running in the background. What's happening is it's doing a search, doing a query on publicly available information in that into that Goldilocks zone. Not everything. In this case, it'll just be news, as you'll see here. 10 pages of 10 each, so roughly 100. At the same time, bringing together the stock information, which is current. And for each one of these, also generating the sentiment, so tearing into opening each one of these articles and getting the tone or the sentiment of what's being talked about. So you can then be in a position to change perhaps the lineup. Let's do, well, this is up to June, right? So if we line this up a little bit closer to where we are, then what you have is this up and down of the stock relative to any change in the sentiment over the same news range. It gives you a one-to-one examination of how sentiment being reported in the news affects stock prices. It's a very simple idea, but the only input, of course, is the news itself and the stock as being reported by the New York exchanges. And of course, you can change this at any time. If I was enamored with AMGN, I just happen to know the stock symbol there. You can go back and do it all over again, right? I have something else I need to check with. So here's another 100 articles about Amgen, and we see the stock price and the sentiment on that news moving around. So again, information in, analysis, interactive reporting. Now here's a model that's a little further afield, not directly focused on competitors, but because competitive intelligence is the business environment, not strictly always just another company. This model is looking at what's called net promoter scores. So would a customer recommend my brand perhaps, or perhaps another person's brand? And so here's a model, because we had enough data to look at survey-based information, as well as what happened during a customer service call. So the amount of time that was taken during the service call, how long the person had to wait to talk to somebody, whether or not the issue for the customer was resolved in that call, or they had to call back, and then and the effect of 1, 2, and 3 of these things on these net promoter scores. So the chances of receiving a net promoter score where 8 and 9 are the definition of I would vote for, or I would tell someone else about your brand. You see here the schedule for 9 versus 8. So this is the probability that I would recommend this brand about 55% of the time if I didn't have to wait at all, and my issue was resolved, and it only took me 6 minutes to talk it through with a customer service representative. But what happens if it takes me an hour? You'll notice the scale changed. Now it starts at about 45, excuse me, and declines more precipitously. What happens if I do all of that, if I wait 40 minutes to get on the phone, then talk for 60 minutes, my chances of receiving a promoted promotion on my brand are pretty low, 35%. What if I don't solve the problem? I start at 20 and I decline even at a faster rate. So this is a predictive analytics model. It's based on input data that's publicly available, but it's put through its paces in a modeling or a machine learning or predictive analytics way, and then it's put back out so that it's interactive in a way that allows you to ask questions, assume things, look at the data in a different way. All right, so there's a different, yet another example of predictive analytics and use of big data. By the way, in current architecture, you wouldn't build these things unless you could keep them live. So behind the scenes, there's an update to this, both input data and the predictive analytics that go with it. And there's a fantastic array these days of technology that allows you to do that. Most of that is cloud-based. So everyone's heard of Amazon cloud computing. They have a fantastic array of available technologies that allow you to put things like this together. You'll also see offerings from the likes of, say, an IBM or a Microsoft for predictive analytics. They have really a nice set of both tools to build those models, but then lots of other tools around that to ingest data, to crawl and ingest data on the front end, then do the predictive analytics, and then help you generate applications like this. We do this at Big Data Lens. They, of course, do it on a much larger scale and also more expensive scale. So that was a good example of some interactivity. Now let me show you something completely different. This is a technique called technology sequence analysis. It's an effort to specify inputs into subsystems into finished goods. Let's say you were faced with the task of wondering among all alternative ways of powering a personal plane. This is just made up, so just bear with me. If you were to think about what it would take to finish a personal airplane, and the inputs to that, you would need power, navigation, some ability to payload, being yourself mostly, or maybe some other luggage, let's say, and surveillance, some ability to look out and know what's coming at you, which is different than knowing where you're going up here. And for each of these, you can see that these are connected by an and. So power, you must have all four of these to have a personal plane. But how you power the plane could be with electricity, gas, or solar power. Again, some of these might seem a little far-fetched, but the point is to look at alternatives, cell, radio, electronics, and so on. Each one of these gets specified with a probability, a time, a cost, oops, I'm losing my inputs here, and a performance. So what we're trying to do is specify what is believed to happen, or the parameters around these, and then the alternatives have the same parameters, including the personal plane. This is called simulation. It's a Monte Carlo simulation. If we can imagine such a thing, if we have background secondary research that supports the probability of a power system for a personal plane, people are working on it in a lab, companies are toying around with it, they have demonstration projects, you can begin to pull these together, add them to a system that we've built, as you see here, and then simulate it. So I'm going to run it 1,000,000 times. And what's happening is we're rolling the dice. And sometimes electricity comes up as the power, and sometimes solar comes up as the power source, and so forth. And when we're done, you'll see the most likely path to finishing this product. You see at the bottom, these are connected by and, so we have to have both of these. But I may have also, let's say, a look at what is the shortest time. So I'm not just interested in the most likely outcome, but I may be interested in the trade-off. How could I get there faster? If I chose gas over electric, it might save me time to finish the good. What's the lowest cost? Perhaps solar as opposed to some of these others. Now it gets really interesting when you change the view of this. Because it's simulation, there are lots of outcomes, and they're probabilistically based. So very much in the vein of competitive intelligence, there is the tolerance for risk. And that's what it tells you over here, the probability of something occurring. If my tolerance for risk is at about 80% time, the simulation tells me if my risk tolerance is 80%, it's going to take about 18, maybe 19 months to complete that particular good. But when it's done, that same risk tolerance would have a 5 out of 10 performance level and a 4 out of 10 cost level. So these are schedules that give us an ability to trade off time and risk, or cost and risk and cost, or risk and time. And these graphs are, again, representations of the same thing. So the most likely outcome would be the peak of this bell-shaped curve. You use these to ask questions like, if you modeled this for the outcome of a new plant and equipment for a competitor, you would get a range of outcomes. Gee, we think they're going to put this type of equipment in, but they might put a different type of equipment in the plant. And you run it forward, and it would take X amount of time, and it would have a performance and cost parameters. And you use this, again, with executives to say, if we're worried about competitors being able to produce 200,000 units a month, their chances of achieving that are only 60%. Ah, I feel better. But if the answer instead is they have a 92% chance of producing 200,000 units every month, that's quite a bit different answer. So simulation helps us bind the outer edges of what's possible, and then give us a chance to interrogate those boundaries so that we know what the chances of something occurring are. And you can work that the other way, by the way, just like I indicated previously. My tolerance for risk is 80%. What's the level? Well, I'm worried about this level. What are my chances it will occur? So again, binding the problem, simulating, interrogating. This is how big data becomes alive and impacts good decision making. Let me stop there. We have about 20 minutes or so, I believe, so that I can answer questions. I see we have, roughly 75, almost 80 people online. And so we want to give everybody a chance to ask their questions. So please fire away, and I'm happy to do my best in the time that we have left to answer your questions.
It looks like we've got one question that it says, are you primarily using Hadoop for this, or other programs, tools, or software?
Yes, good question. Hadoop is all the rage, but it is certainly not complete as an analytical platform. You should think of Hadoop as a large data repository, data manipulation engine in which you can parallelize processing. That simply means Hadoop is very good at taking what you would have done in a traditional relational database, and if you're trying to grow that extremely large, that relational database will slow down. It's inevitable. So Hadoop exists to say, well, let's beat that problem by chopping up the problem and distributing the data across all kinds of smaller versions of a database. And Hadoop will keep track of where the data is and what it needs to do, but run it in parallel. You could think of it that way. The other way to think of Hadoop is that you move the analytics to the data rather than move the data to the analytics. So in a traditional sense, a SQL or a relational database, you would have to get the data out of the database in order to apply the analytical models, not unlike what we've shown here today. So you would have to move the data to the analytics. Hadoop is good at saying, well, no, leave the data where it is. It's distributed all over the place. Leave it where it is, because moving data is very time consuming, and it takes up a lot of space across your network or the internet. So don't move the data. Move the analytics to the data. Leave the data where it is and just move the analytics to it. So that's where we're going. It's still under lots of development. So I think that paradigm, whether it's still called Hadoop, will be very powerful in the future. But to answer your question directly, there's plenty that can be done without Hadoop. Some of the things I've shown here today were done with simple copies of R, which is an open source analytics or predictive analytics machine learning environment in which you can write your own algorithms, run them, test them, and deploy them. The deployment in some of the things that I showed today is a little platform called Shiny, also a R compliant kind of environment. So the tools you choose will largely depend on the size of the data that you think you're going to need. But it's surprising how much you can do short of diving into the Hadoop pool when it comes to data acquisition, analysis, application development, like I've shown here today. I hope that answers your question.
Great. Thank you very much, Brooke. I've got another question from Peter. He's wondering about cost, and it seems like that these projects would be difficult to manage. And any advice as people consider these projects against various initiatives?
Right. Well, what's surprising today in the, as I indicated earlier in the last question, a good deal of this doesn't have to be industrial scale. In fact, I would, even if you have to move to a Hadoop type scale in the future, which is also open source, by the way, but that doesn't preclude you having to rent or buy space on a cloud and the machines that go with it and so forth and so on, and the people to help you organize it. That does get expensive. But I would never start there. From a predictive analytics perspective, even when you're talking big data, start small. Start small with a copy of R. Start with simple models. Start with descriptive statistics. Start with what's open source. Start with a project that you outsource to an outsider to rapidly develop and show the way. Everything I showed, these things that I showed in the browser over here, this application or this application, these cost me $40 a month for an unlimited number of those, and I've developed those using R, which is open source, so that cost me nothing. So there's really a big range. I can't be more specific than that, of course, but except to say start small so that you know what you're getting into before you scale it to Hadoop. I see way too many people jump in and say, well, it's got to be Hadoop, and before you can blink, you've got 10 guys in a room who are costing you $80 an hour fiddling with Hadoop. So I wouldn't go there first. I would start small.
Thanks, Brooke. Really appreciate it. Looks like that's the end of our questions. And I just want to take a minute here to thank Brooke once more and then Xana for this great webinar today, and also Aurora, WVC, once again, as our wizards behind the scenes hosting these webinars for us. And if anyone would like the recording, it will be available very soon as we can get that out, and that will be available to all attendees and registrants. So once again, thanks a lot for joining the Competitive Intelligence Division today, and we'll see you again soon. Thanks. Bye-bye.